Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, if you wish to, excuse me, I can't read. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting, but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So I will be looking over the tests this afternoon to see if people got any partial credit points for work submitted to wrong answers. Anyway, I'll try and get that done today. If you have any questions about the test, please come to my afternoon office hour or email me and I'll get in touch with you when I can, but I'm not going to spend class time going over the test. Anyway, today, we're going to start chapter 7, and we're going to actually cover two sections of chapter 7, 7.1 and 7.2. So let's go ahead and get started.
Can I ask a quick question?
You can even ask a slow question if you want. What's up?
So I'm not sure if it's fixed now or if that's how it's going to be. I seen on the homework that there's not one due today, rather there's two tomorrow that are due.
That is true. Because
what's the reason?
Okay, so there's two assignments that we're going to cover today. Okay.
Okay.
So they're both due tomorrow night. And something that some of you, and this may not have to do with you, Armando, but something that some of you haven't figured out. The assignments today, you should be doing them and finishing them today. Then if you have questions, tomorrow you come back during class or office hour and you ask questions so that you can get them all wrapped up by tomorrow night. What some of you are doing, what some of you are doing is thinking, oh, it's not due till Tuesday night. So about 10 o'clock Tuesday night, you start doing your homework. And that doesn't work. Technically, if I put it that was due tonight, then people would need extensions. So it's like, you're supposed to work on it, get it wrapped up by tomorrow night. But tomorrow there's a new assignment. Anyway.
Okay. Sounds
good. And there's a lot of material to cover, and to keep up with the schedule, we have to cover two sections today. That's the way it is. But anyway, so don't wait till tomorrow at 10 o'clock to start 7.1. Okay. All right. So we're going to look at something called simplifying rational expressions. A rational expression is basically a fraction that contains at least one variable. So it's an algebraic fraction. We call it a rational expression. And the whole thing, chapter 6 was all about factoring. We're going to continue using factoring in this next chapter. So if you liked factoring, you're in good shape. If you didn't like factoring, well, anyway, moving on. All right. Let me ask you this. What is x minus 8 divided by x minus 8? Anybody?
0?
No.
Is it 1?
It's 1 because it's a number divided by itself. Doesn't x minus 8 represent some quantity? So a number divided by itself is going to reduce down to 1 unless it was 0 over 0. Okay, like what is 9 divided by 9? That's 1. Negative 12 divided by negative 12 is positive 1. So a number divided by itself other than 0 is equal to 1. Okay, now, what about x plus 8 over 8 plus x? What's that equal to?
1.
That's also equal to 1. Keep in mind addition is commutative, so really that's the same thing as this. So it's just like the last problem. We've got a number divided by itself, so it's 1. Okay, what about this though? X plus 8 divided by x. We can't simplify that. Okay, so it does not simplify. And then the last one I want to look at, I kind of want to build up to it. What's 7 minus 3 over 3 minus 7? Well, let's see. What's 7 minus 3?
4.
What's 3 minus 7?
-4.
What's 4 divided by -4?
-1.
-1. Okay. What's 10 minus 2 over 2 minus 10? What's 10 minus 2?
8.
What's 2 minus 10?
-8. -8.
What's 8 divided by -8?
-1.
Okay. What's 12 minus 5 over 5 minus 12? Well, let's see. What's 7 minus 5? Excuse me. Whoops. What's 12 minus 5?
7.
And 5 minus 12?
-7.
And what's 7 divided by -7?
-1.
Okay. So a number divided by its opposite, other than again 0 divided by 0, is going to divide out to be -1, right? A number divided by its opposite. And in each case, this is the opposite of that. This is the opposite of that. This is the opposite of that. Okay. How about this one? What's dog minus cat divided by cat minus dog? What?
Dog.
No, it's -1. Aren't these the opposites? Look at the pattern here. 7 minus 3 is the opposite of 3 minus 7. 10 minus 2 is the opposite of 2 minus 10. So dog minus cat is the opposite of cat minus dog. So they reduce down to -1. You see it?
Yeah, now you do.
Okay, all right. I know it's all gone to the dogs. Okay, now, how about this one? X minus 8 divided by 8 minus x. What's that equal to?
-1.
-1. Good job. Because these two numbers are opposites of each other. Okay. All right. Now, let's say I've got 7 times 6 over 7. Does that reduce down to 6?
Yes.
Yeah, because 7 divided by 7 reduces down. These are factors we can reduce it. What about 7 plus 6 over 7? Does that reduce down to something?
No.
In other words, can I cross those out and just get an answer of 6 or 6 plus 1 or something? Can I do that?
No.
No, you're right, because these are terms. You can't reduce terms. You can reduce factors, but you can't reduce terms. That is the biggest concept in this chapter, that right there. You've got to remember it and apply it. You can't reduce terms. You can reduce factors if they are factors of the entire expression. Okay, and you're going to hear that so many times from me. Okay. So let's take a look at this problem. 3x minus 2 over x minus 2. It says, evaluate this expression for x equals 6. So this would be 3 times 6 minus 2 over 6 minus 2. Can I reduce the 6's out?
No.
No, because of that. Okay. So this becomes what, 18 minus 2 or 16 over 4. Can I reduce this down?
Yes.
Yes. Good. I know you're all so timid. It's like, I don't want to answer. It's going to be wrong. You'll be fine. Okay. Now, take a look at this expression, 5x over x plus 5. It says, find all real numbers for which the rational expression is undefined. Tell you what, before we do that problem, let's do a little bit of review. What's 0 divided by 7?
0.
0. Careful. What's 7 divided by 0?
Undefined.
Undefined.
Good. Undefined. You can't divide by 0. It's all fun and games till you divide by 0. Then, you know, the universe collapses. Okay. So back to this expression. If the denominator was 0, in other words, if this was that, we'd be in trouble because then it would be undefined. So what value or values of the variable would this be undefined? Or another way of saying it is, when would the denominator be 0? What would x have to equal for the denominator to be 0?
-5.
Right. So if we had this, we'd be in trouble. So it says for all, find all real numbers for which the rational expression is undefined. So you'd say for x equals -5. This expression is undefined when x is -5. Okay? Take a look at this expression, 4x minus 1 over 6x. For what value or values of the variable would this expression be undefined? When x equals what?
-6.
No, because if x was -6, that would make it -36. Don't confuse that with this. Here, these are being added. Here, they're being multiplied. So 6 times what would be 0?
0.
There you go. Okay, so be careful. How about this one? X cubed minus x squared over 15. For what value or values of the variable would this expression be undefined?
Zero.
But you can't make the denominator 0. If you put 0 in for x, you're going to get 0 cubed minus 0 squared, which is 0, and 0 over 15 is still 0. So there are none. Oops, because the denominator can't be 0, so it can't be undefined. When is it undefined? When the denominator is 0. Okay? Tricky stuff, I know. All right. 2x minus 15 over x squared minus 49. So for what value or values of x is this thing undefined?
7.
That's true. Anything else? So here's the question. When is x squared minus 49 equal to 0? Well, let's see. Let's see that we'd have to factor it, and then we'd get that, and we'd get that. And here's the answer that you gave, but there's also that answer. X is -7 or 7. Both of those make it undefined. Do you see that?
Yeah.
Okay. So what are you doing? Basically, you're taking the denominator and saying, when is it 0? Set it equal to 0 and solve it if you need to see that there's both answers there. Okay. New set of directions. This basically says simplify. So 48 over 16y. Can I reduce that anyway?
16.
Yeah. What's 48 divided by 16?
3.
What's 16y divided by 16?
Y.
1.
Yeah. So 48 over 16y reduces down to 3 over y. Everybody okay with that? All right. 4x plus 12 divided by 16. Simplify. Can I reduce the 4x and the 16?
Yes.
No, because the 4x, those are not factors of the entire numerator.
Oh, that's
Darn.
right.
Forgot the sign.
Can I reduce the 12 over 16?
Yes.
No, because the 12 isn't, the 12 isn't a factor of the entire numerator because of that.
So basically, that's just the answer.
No, boy, I'm just so mean today, aren't I? Here's what we can do. We can take the numerator and factor it. Okay. See what I did there?
Yes.
Now I can reduce that because the 4 is a factor of the entire numerator and the 16 is a factor of the entire denominator. So I can reduce this down to 1 over 4 and my final answer becomes x plus 3 over 4. But I can't reduce terms, but I can reduce factors. Isn't that that thing he said about 10 minutes ago that he said he was going to be saying over and over? Yep. You're going to be so tired of hearing that. The sooner you get it, the less I'll have to repeat it. So there's the good news. Okay. Let's take a look at another one. Are you ready? Here we go. 2x minus 14 over x minus 7. Can we reduce the 2x over the x? Everybody's afraid to answer now.
No.
No. Why not?
It's a term.
Right. Can we reduce the 14 over the 7?
No, but we can factor out a 2 on the top.
Yes. Good job. Can factor out a 2. Now, the factors of the numerator are 2 and the quantity x minus 7. The factor of the denominator is the whole thing x minus 7. Can I reduce the x minus 7 over x minus 7?
Yes.
No.
Yes, I can.
Yeah.
Because the x minus 7 is a factor of the whole numerator. I know you were going to, I know. So the final answer is 2. Okay. We're having some fun now. All right. How about this one? Y squared minus 25 over y squared minus 3y minus 10. Okay. Can I reduce the y squared over the y squared?
No.
Why not?
It's not in the whole thing, is it? It's like a term still.
Terms. Can I reduce y squared over 3y and take a y out? No. Terms. Can I reduce the 25 over the 10? No. Terms. Okay. But if I factor the numerator and the denominator, now, are there any common factors I can reduce out?
Y minus 5.
Yes. Final answer, y plus 5 over y plus 2. Why is that a factor of the entire numerator? Because it's being multiplied by everything else. This is being multiplied by everything else. You can reduce out common factors. You cannot reduce out terms. Okay. Let's see here. How about this one? X squared minus 10x plus 21 over x squared minus 3x. Can I reduce the x squared over the x squared?
No.
Can I reduce the 10x over the 3x?
No.
Can I reduce the 21 over the 3?
No.
Why not? Because they're all
Term.
terms. So what are we going to do? Factor. So I factored the numerator and I factored the denominator. Now, are there any common factors in the numerator and the denominator?
X minus 3.
So I can reduce that out. So now I've got x minus 7 over x. But wait, can I reduce the x's now?
No, isn't the top one still in a term?
Correct. I cannot, because that x up top is not a factor of the whole thing. Okay. How about this one? 18 minus d over d minus 18. Can I reduce that or simplify it?
Yes.
What is it?
-1.
Doggies and kitties. Meow. Good job. You remembered. I'm so proud. Okay. How about that? Does that thing reduce?
Yes, you can factor out the bottom, right?
Excellent. So now what?
And then, oh, this is confusing.
What's that right there?
That's -1.
Right. So that is -1. So now we've got -1 over 3. Now, people are going to say, well, does the -1 go on top or on the bottom? It doesn't matter. In the end, you're going to want it ultimately. In the end, you're going to ultimately want it in the numerator or out front. So -1/3. Okay. But this over this reduces down to -1 over 1. So you got -1 times that, which is where we got that. Okay. All righty. How's about this one? 81 minus y squared over y squared plus 10y plus 9. So basically, what do we need to do before we try to reduce? I'm thinking of a word. It starts with F and it rhymes with actor.
Factor.
Yes. Good job. Be careful. Are there common factors?
No.
That's y plus 9.
Sorry?
Y plus 9.
The y plus 9 and what?
9 plus y.
Right, these two. What do those reduce down to?
1.
Just 1, right? Those aren't opposites. So that's just 1 over 1. So we get 9 minus y over y plus 1. Okay. Let's see here. How about this one? X squared plus x minus 6 over x squared minus x minus 2. Will this reduce?
No.
After we factor it, won't it?
After we factor it, maybe. So the answer should be factor it and then we'll see. Okay. Let's see, product is -6, sum is +1. How about +3 and -2? Product is -2 and sum is -1. How about -2 and +1? Is that right? Is that factoring it correctly?
Yes.
So then common factors reduce out, x plus 3 over x plus 1. So before you don't judge a book by its cover, right? Factor it and then see. Okay, how about this one? So what do we need to do first?
Factor the numerator.
Okay. Difference of two squares. Squares, difference of two squares. Can we do anything with the denominator?
Factor out the 5.
Okay. And oops, that shouldn't be a 5, it should be a 1. Like that. And can we do anything now? Nope, we can't do anything. It doesn't have any common factors. We factored the numerator and the denominator, no common factors. All right. Let's see here. How about this one? 5y squared over y plus 5. Can we reduce that? Sorry, I just washed my tongue and I can't do a thing with it.
Don't we factor out the 5 on the top?
And then we just get 5 times y squared.
Oh, yeah, never mind. It does,
That's
it
okay.
doesn't factor or simplify.
So can we reduce the y squared and the y?
No.
Can we reduce the 5 and the 5?
No.
Does not what simplify? I was going to say does not reduce, but same thing. Man, I know you'll find this hard to believe, but I got a C in writing in 6th grade. You're probably thinking that was a gift. Okay, simplify. All right. We're going on to section 7.2, which is multiplying and dividing rational expressions, which means multiplying and dividing algebraic fractions. Let's review how you multiply algebra, just fractions in general. Let's say you've got 2/3 times 1/5, okay? I can't reduce anything ahead of time here, so my final answer is 2/15 because you multiply straight across. Let's say I've got 2/3 times 6/5. Can I do any pre-reducing before I multiply it out?
The 3 and the 6.
Yeah, 6/3 is 2/1, and then I get 4/5. Right? Does everybody remember that?
Yeah.
Okay, let's jump right in then. Here we go. 2/7 times z/3. Can I do any pre-reducing there?
No.
No, so I get 2z/21. How about this? How about 11m/21 times 14/55m²? Can I do any reducing there?
Wouldn't it be 11?
Sorry? I didn't hear that.
The 11m and the 14 and 21.
Okay, the 11m. What are you going to reduce it with?
So 55m to the 3rd.
Okay, so 11/55 would be 1/5. Okay. m/m³ would be 1/m what?
2.
2.
2 squared. Okay, everybody still with me? 14/21, we take out a 7, we'd get 2/3. So on top, I've got 1 times 2, which is 2. On the bottom, I've got 3 times 5 times m², which is 15m². Okay with that? We good to go on?
Yeah.
All right. A minus 9 over 9. Why do they put A's and 9's in the same problem? I'll never know. Times 8A over A minus 9. Are there any common factors I can reduce out?
A minus 9.
Yeah,
Both ends.
yeah. Can I reduce anything else out?
No.
So I've got 8A over 9. Suppose I've got 3y minus 9 over y minus 3 times y over 3y squared. What do I need to do? Starts with an F.
Factor the 3y squared.
Well, it's already 3 times y, but what other thing could we factor?
You factor 3y minus 9.
Right. And 3y squared, I mean, you could write it as 3 times y. You could do that. But now what can we get rid of on top and bottom?
Y minus 3.
Okay, so that becomes 1 over 1. Anything else?
The 3.
The 3 over 3 becomes 1 over 1. Anything else?
One of the y's.
Y over y becomes 1 over 1. So what have I got in the numerator?
1.
And in the denominator?
Oh, sorry. The numerator is y, and then the. Oh wait, no. Yeah, sorry. 1 over y.
Right. Now be careful, because I'll have students that'll just write this because they think that there's nothing left in the numerator, but there is. There's a 1 there, right? We're not canceling things out. We're reducing them down to 1 over 1. So it's not equal to just plain old y. It's equal to 1 over y. Okay. How about this one? P squared minus P minus 6 over 3P minus 9 times 2P squared minus 5P minus 3 over P squared minus 3P. So before I try to reduce anything, what should I do first?
Factor.
Good. All right. P squared minus P minus 6. We'd have a P and a P and a minus 3 and a plus 2. Product is negative 6. Sum is negative 1. Three P minus 9 will factor out a 3 and we get P minus 3 left. P squared minus 3P, factor out a P and we get P times P minus 3. And then there's this one. Okay, let's see here. Do you want to use grouping or guess and check or trial and check?
Grouping.
Grouping.
Okay, so A is 2, B is negative 5, C is negative 3, product is negative 6, sum is negative 5. How about negative 6 and 1? So we get 2P squared minus 6P plus 1P minus 3 which is 2p times p minus 3, p minus 3 plus 1, which is 2p plus 1, p minus 3. Okay? And if you're sitting there totally lost, you need to go back and review chapter 6. Because this is what we did back in chapter 6. Okay? So now what can I reduce out?
Both of the p minus 3s.
Yeah, this one will go, and that one will go. Anything else that can be reduced out?
No.
Okay, so I've got p plus 2, 2p plus 1 over 3p. And the instructions might say to leave it factored, or it might say to multiply it out. If it doesn't say to multiply it out, you could just leave it factored like this. In other words, you don't need to take these and multiply them back together unless it says to. Okay? All right, now let's go back to arithmetic. If I've got 2/3 divided by 4/7, if I've got a fraction or a whole number divided by a fraction, what's the first thing you do?
Common denominator.
What, Jordan?
Was it find a common denominator?
No.
With the reciprocal or something like that?
Yes, dividing by a fraction is like multiplying by its reciprocal. Yeah, when we're multiplying or dividing fractions, we don't need a common denominator. That's only when we're adding or subtracting fractions, okay? So dividing by a fraction is like multiplying by its reciprocal, as I like to call it. Now it's a multiplication problem. Can I do any reducing ahead of time?
Yes, the 2 and the 4.
Yeah, so this is 1 over 2, and I get 7/6 as my final answer. So change division to multiplication of the reciprocal. Okay. So now, let's say I've got 3 over a divided by 9 over 5. So that becomes 3 over a times 5 over 9. Then I can come in and reduce the 3 to a 1 and the 9 to a 3. And I end up with 5 over 3a. You see how that's working? All right. Let's crawl out into the deep end, or maybe dog paddle out into the deep end. Let's say you've got x squared minus 2x minus 35 over 3x squared plus 27x, all of that divided by 3x squared plus 17x plus 10, all over 18x squared plus 12x. What's the first thing we're going to do?
Do we factor first or do we find the reciprocal?
I would change it to multiplication, because if you factor it first, you might be tempted to reduce across that, and you're not supposed to do that. So I would rewrite it as a multiplication problem. Okay, so it's going to become x squared minus 2x minus 35 over 3x squared plus 27x times the reciprocal, which is 18x squared plus 12x over 3x squared plus 17x plus 10. So change dividing by a fraction into multiplying by its reciprocal. Do that first. That's the safest way to go. Then the next step is going to be to factor everything. Okay. X minus 7, x plus 5. I'm going to factor a 3x out of the denominator, 3x, x plus 9. 18x squared plus 12x, I'll factor a 6x out and have a 3x plus 2. I left the worst one for last on purpose. Okay, so now 3x squared plus 17x plus 10. A is 3, B is 17, C is 10, the product is 30, the sum is 17, the numbers are 15 and 2, 3x squared plus 15x plus 2x plus 10, 3x, x plus 5 plus 2 times x plus 5, x plus 5, 3x plus 2. And I know I went through that kind of quickly. X plus 5, 3x plus 2. So here I just used factoring by grouping. So now everything's factored. What can we reduce out?
The x plus 5,
Okay,
the 3x plus 2.
anything else?
Nope.
But there is.
If you divide 3x by and 6x,
Okay, 6x over 3x would be what? 2 over 1?
2/1, yes.
Is there anything else I can reduce out?
No, that's it.
So my final answer, 2 times x minus 7 over x plus 3. Yeah, don't be fooled. Things don't have to be in parentheses to be a factor. So that 6x and the 3x, those reduce, even though they weren't inside of parentheses. Okay. Okay. How about, well, wait a second here. We good to go on? All right. How about this one? N squared minus 10n plus 9 all over n minus 9 divided by the quantity n minus 1. So what would be the first thing to do?
Reciprocal.
Right. So this would be n squared minus 10n plus 9 over n minus 9 times 1 over n minus 1, which would be the reciprocal of n minus 1 over 1, right? What do we do now?
Factor.
Sorry?
Factor.
Factor, okay. So what'll reduce out?
N minus 9, n minus 1.
So what are we left with?
1.
Just 1.
Yeah, the whole thing reduced down to 1, didn't it? Great. How many of you took Math 75 here at YVC? Anybody?
Me.
Okay.
Yeah.
Do you remember that whole chapter on unit conversion factors, like converting one unit to another kind of thing? Well, let's see. We'll see if you remember it. Okay. So here we've got, it says complete each unit conversion. 150 yards all over 1 times 3 feet over 1 yard equals what? So what could you get rid of?
Cross out the yards because they cancel each other out.
Yep, we could get rid of the common units. And we'd end up with what? 3 times 150, which is 450
Feet.
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 Excellent. Okay, let's do one more of those. Let's say we've got 4 cups over 1 times 1 gallon over 16 cups. So what could we get rid of?
Cross out cups.
Cups.
Anything else?
And divide 4 and the 16.
So 4 over 16 would become 1 over 4.
4
So we end up with 1/4
gallons.
gallon. Okay. Let's see here. We've got time for one more. Let's do this. 3a cubed b over 25 cd cubed times 5 cd squared over 6ab. So this kind of goes back to some of the first stuff we looked at. Can I reduce anything? Everything's already kind of factored, isn't it? I mean, we could pull a cubed apart and write it as a times a times a, but we shouldn't need to do that to be able to reduce it. What'll reduce? Anything?
And the
Yeah.
6 and the 5 and 25.
Okay, so 3 over 6 reduces to what? 1 over 2.
And
5.
25.
That reduces to 1 over 5. How about the variables? Anything there?
C.
What about the C?
Are they like grouped together or are they separate? Like the CD? As if
Well,
they're-
to answer your question, I'd say yes, they're grouped together and they're separate. They're separate, they're factors. They're all one product, but yeah, you could take C over C and get a 1 over 1.
yeah, and then the D squared over the D to the third would give you a D on the bottom. And then for the A and the B, it would be A squared on the top.
A square.
Okay, so that'd be A squared over 1, and then,
The B's would just be 1.
You cross out.
okay, so up on top, what have I got?
A square.
And in the denominator,
5, 10, D.
there you go. All righty, excellent job. So I